As pilots, when we begin to fly, we are instructed to diligently follow procedures. And I can tell you from my own experience that the more flying I do, the more I realize that checklists and procedures are critical tools to complete our jobs safely and successfully. But I'll admit that I do scratch my head from time to time trying to figure out why our operating procedures are designed the way they are. And sometimes I understand the thinking and the mindset of those who created the procedures, but there are some other times when I do not. And fortunately for all of us, ALPA has experts who think about the tools we use and how they need to evolve in the future. And our next panel will focus on human-centered operating procedures. And to lead this discussion is Captain Frank Cheeseman. Captain Cheeseman is our Human Factors and Training Group Chair for the ASO. Frank?
It's a pleasure to be here today, and it's really special to see a large crowd here as well. I'm going to name some names. I'm going to put a batting order lineup out here, and we'll see if most people remember these names. Here we go. Sumwalt, Decker, Dismukes, Burien, Barshi, Orlady, Krasnicki, Fenwick, Hanlon, Cunningham, Noy, McKinney, Abbott, Hogeman. These are the people that have said and advocated a change in how we think and how we operate in our cockpits. And if you look at the history of our business and our profession, the mechanics and the engineers have done a phenomenal job. Simply stated, the airplanes virtually don't break anymore. And if you look at the statistics, clearly a large number, if not overwhelming number, over 80% of our accidents now are solely caused by the human element. So this time last year, ALPA sat down in the ASO leadership team and put together an idea that this would be our year of human factors. And we put political and financial resources behind it. And we've had a great discussion during the workshops. You can see the crowds yesterday. We had overwhelming support, filled rooms when we're talking about human factor and how the human factor plays a role in our business and how we can do a better job. Now, what's changed is over the last 10 or 20 years, we now have a lot of research and data. The question is, are we going to apply that? Are we going to take it and move it effectively into the cockpits, or are we just going to sit on that data and say it's nice to have? Now, having said all of that, I want to reiterate and remind people that we are doing a fantastic job. Our pilots are doing amazing work, and we only hear about the famous saves each day. We only hear about the famous ones that make the press. But there's literally hundreds of great decisions being made every day that we don't know about. But that said, we have to make a decision as a profession. Are we going to improve, or are we going to say that's good enough? And I think most of us in the room would say we need to improve. We need to squeeze the last juice out of that orange. And the best bang for the buck, the best bang for the effort is going to be with the human interface. So we can't be satisfied, and ALPA will lead the way. And we have done that for years and decades. We'll continue to do it, and we're doing it again today. This isn't the end of the year of human factors at Airline Pilots Association. It's just really the start. And how do we know that we can do better? One of the things you'll hear today is the results of implemented changes on how an airline does business. How do we know we need to do these things? We have data that supports it. LOSA tells us that we can do better, and LOSA can also tell us that we are doing better. So that's the interesting part of where we're at. The next leap in human factor, or the next leap in safety, will be as a result of the human element. So with that said, we have a fantastic panel today. You can read all their bios in your app, and some people say that's on your computer. I heard you can also take a photo now on a phone, but that's another joke. That's supposed to be a joke. coming towards the end of my career now. But we have Sathya Silva from the NTSB. Thank you for being here. We have Immanuel Barshi from NASA. What a great lineup. Rich Loudon from Alaska Airlines, and Helena Cunningham from the Airline Pilots Association and Delta Airlines. So with that said, to talk about the history, to talk about maybe a couple incidents that'll tickle your mind again and get you going on this, Sathya, you have it.
Thank you, Frank. Thanks for the introduction. I'll discuss two accidents that I've chosen today where checklists and standard operating procedure design issues with those were apparent in these cases. So this is a DC-9 that landed wheels up in Houston back in 1996. Fortunately, in this case, there were no fatalities or serious injuries. The investigation itself unearthed many issues, mostly regarding the crew and others, but specifically, they found issues regarding the checklist design within the cockpit. So in this case, the aircraft landed gear up and flaps up, and the reason for this was that there wasn't sufficient hydraulics pressure in the system. The reason for this was that there was one critical step that was missed in their in-range checklist, and this was to confirm that the hydraulics were on and set to high pressure. This item specifically consisted of 3 actions, two of which were moving switches. The next one was confirming the hydraulic pressure. And keep in mind, the way that this checklist was written, the only response to the hydraulics item was checked. And there has been research, and especially at that time, actually out of NASA Ames, that showed that actually having a verbal confirmation of the pressure value in this case actually improves compliance with procedures. So there was some room for improvement there. In addition, at the time of this accident, there was also the way that the procedures were conducted. Both the challenge and response of a checklist item could actually be done by the same crew member. And that undermines the redundancy that was built into having a challenge response checklist. And finally, again, regarding the checklist issues here, when investigators looked at the in-range checklist, the hydraulics item was found pretty low on the checklist. And that is a location where they're more prone to omission. And so, again, going into prioritizing safety critical items on the checklist and making it more human-friendly, friendly for the user. So after this accident, the airline did work to apply human factors considerations into their checklist design in order to prevent crew members from omitting items and also to promote redundancy and also to prioritize the safety critical information. And this accident, again, was 1996. It was a little while ago, and this was one of the motivating cases really for human factors in procedure design. And I'm sure you're thinking we've come a long way from there. A lot of these things are probably commonplace for you now, but remember, we did have to come from somewhere, and the progress is still there, but there's still a long way to go. Next slide, please.
Sure.
So the next case I'll bring up is a King Air that impacted terrain in Minnesota back in 2002. This was a Part 135 operation, and it got specific coverage because Senator Wellstone was on board. And unfortunately, in this case, all 6 passengers and 2 crew members perished in the accident. What happened here was that the aircraft stalled as it flew through icing conditions while on approach to the airport. And again, as you can imagine, the crew got cited in these in our probable cause for this. But again, there's also quite a few standard operating procedures that were missing or inappropriate, really. And those issues were readily apparent in this case. One specific one was that this was a 2-crew operation, and there was no guidance or checklist to conduct an approach briefing. So both crew members were not necessarily on the same page when it came to conducting the approach. There was also, interestingly enough, in one of their manuals, it was required to do an in-range check, but an in-range checklist did not exist for this company. So that one kind of tells you the discrepancy between what you may have in the manuals versus what people are actually flying. And specifically for this accident, with the sequence of events, you had essentially a lack of preparation earlier in the approach, which caused an increase in workload towards the end, which did contribute to the accident itself. So having that in-range checklist and having it consistent would have benefited here. And again, this was a stall, so it was a loss of control, and the company actually didn't have guidance regarding stall recovery initiation procedures or any guidance on what to do, how to respond if the stall warning horn sounds in flight. In addition, there was guidance in multiple of its manuals on when to operate the de-icing boots that was also inconsistent. And in this case, the icing didn't contribute directly to the accident. However, based on the information that we found, it was a stressor for the pilot himself when he was deciding whether to operate the flight and during the flight itself. So this example specifically shows how poor SOP guidance or missing SOP guidance can contribute to fatal accidents. And overall, standard operating procedures have been put in place to address human limitations. Standardization, we're not the best at remembering everything. And so they are very important into the operation, as I'm sure you all know. But poor design or missing SOPs really undermines the benefit that the SOPs provide. And so, and we'll talk about today, I'm sure, it's really important to really consider the person that you're designing it for in order to get an effective procedure. The two examples I talk about today include Part 121 and 135 flight operations. There are multiple examples of this kind of issue throughout the aviation industry, including inside aircraft maintenance. The other thing you'll see is that's kind of up and coming now is issues with organizational issues and culture, things like that. And those tie in very closely to how pilots fly and what they report, what they don't report, and how the operation works as a whole. And so this really is a system that we're working with. Steps have been taken to do further research on integrating the human into design. And again, I'm sure we'll hear about that today. So it's definitely making progress. But again, there continue to be accidents where this occurs, where the SOPs may not have been optimized for the pilot who's actually conducting the procedures. So it's a pretty important issue to discuss, and I'm looking forward to continuing that.
Thanks, Sathya. This reminds me of I was watching a rerun of a MASH episode the other day, and if you all recall that people that have watched MASH, do you remember when Winchester showed up to be a surgeon at the 407 7th, and for every 3 bowel resections that Hawkeye did, Winchester was behind. And Hawkeye said to him, "Winchester, let's pick it up." And Winchester says, "I do one thing at a time, I do it very, very well, and I move on to the next task." So with that said, maybe that was an insight into how we think a little and how our mind works. So Dr. Barshi, maybe you can talk a little bit about that and kind of how we work and how we interface with the system, and maybe the benefits of looking at the human factors environment and blueprint in which we operate.
Thank you. So I'm actually tired of hearing human error. When an airplane flies along and a wing falls off, it was not the wing's fault. Maybe a human didn't design it right. Maybe a human didn't build it right. Maybe a human didn't maintain it right. Maybe a human didn't operate it right. But it was not the wing's fault. So all these statistics about 60% of accidents are human error, 80% of accidents, 100% of accidents are human error. So it's not really revealing to say that this is human error. And the notion of pilot error is also problematic, right? Particularly in 121 operations. It's a crew error. It's not a pilot error, right? It's a crew error. And one of the, and excuse me, Sathya, we're good friends, so it's nothing personal. One of the disappointing things with the NTSB is that the end point of the analysis is that it was a pilot error. That's the starting point, not the end point, right? Because we want to understand, well, why? And when they say that it was a pilot error, what they really mean to say is that the crew was the last to have a chance to prevent the accident from happening, and for some reason didn't. For some reason, they were not able to prevent it. But it's not that they caused it, right? Because when you look at an accident, there are always lots of different pieces that lead to the accident. It's not just the last thing, except for, you know, a German wings type thing. And that's extremely rare, extremely rare. When we think of procedures, we think of procedures as governing the interactions between three major pieces. It's the technology, the human, and the operational environment. And when we come to revise procedures or to design procedures, we need to think about all these three pieces, the technology, the human, and the operational environment. We get the aircraft with procedures from the manufacturer, and the manufacturer is driven by the technology. It's an engineering-driven set of procedures. This is how you operate the machine. And the manufacturers will tell you that they're not operators. They don't want to be operators. They don't want to take the responsibility of being operators. They give you the machine, they give you engineering-driven procedures. You guys that often participate in designing procedures have a lot of experience with the operational environment, and you can bring that perspective in. What we all too often miss in this is the human piece. We miss the part of the human that keeps the system resilient and safe, because we know that people save the day much more often than they make mistakes that spoil the day, right? But humans also have some limitations, and we need to be concerned with the constraints, the limitations, the affordances of all three, of the technology, the human, and the environment. So we recently published a little technical report on the design of procedures and checklists that can be used as a guidance on, okay, how do we go about designing procedures? And the human piece is a critical piece. So in your respective airlines, when you think of procedures, remember, you want to have the technical expertise, and you have technical pilots, you have contact with the manufacturers and so forth. You have your own people with a lot of operational experience. You have your ATC liaison, you have your meteorology department, dispatch, and so forth that can help with the operational perspective. But it's really critical to have the human piece there, because it's us as people that need to be able to use the procedures and use them well. One more thing that I think is really important to think about when we think of procedures. It's very easy for management to come and say, oh, we saw this and that on ASAP or on FOQA or in ELOSA. We have to have a procedure for that. We need to have another line on the checklist. We need to have something so it doesn't happen again, kind of thing. And from management perspective, and I don't know how many lawyers are in the room, but from legal perspective, very often people feel that if we can proceduralize everything, then we will have complete control. Then we will have complete predictability, and we'll know exactly how everything is going to happen. Keep in mind one thing. When you turn people into procedure monkeys, they will be monkeys. And when they're in a situation for which there is no procedure because our imagination is limited and we cannot design procedures for everything, when they will be in a situation for which there is no procedure, They will pick up the phone and call the chief pilot to ask what to do. And we don't want to be there. We don't want to be there. We cannot proceduralize everything. It's actually a dangerous direction to go to. And when we think of procedures, we need to realize that we need to have a coherent and consistent system of procedures. We don't have a single procedure living in isolation somewhere. It's part of a system. And it's a complicated system that have a lot of interactions. And if we make a change somewhere here in the procedure because something happened before push, and we say, okay, so before push we need to add this thing, but we don't think about the rest of the system, and this little piece is inconsistent with the way we actually do things after landing. When we have inconsistencies in our procedures, we're going to lead to selective noncompliance. It's very easy to see, that doesn't make sense to me, that's inconsistent. I'm not going to do it that way. I'm going to do it the old way, or I'm going to do it the way it's done here. So when we think of the system of procedures, every little piece has to fit, and every little piece has to be consistent and coherent within that system. Because we as humans need that kind of consistency. If it's not there, we're going to have trouble with it. It's going to be confusing, it's going to be difficult to learn, it's going to be difficult to remember, it's going to lead to selective noncompliance, and we don't want to be there.
Excellent. Thanks, Dr. Barshi. I think one of the key takeaways so far at kind of the third of the way into this is that this is a system, and that we cannot think of individual pieces, but we have to think about how the blueprint fits together, and how all of the pieces that we do in terms of the human interface build a footprint for a pilot to go in and use that footprint so that it all makes sense to that person, that he understands exactly where the end game is and how it all fits together so we don't wind up with the selective non-compliance. Going back to the MASH analogy, Winchester got back to the tent and he said to Hawkeye, I don't know what to do. What do you want me to do? And Hawkeye said to him, I don't know, just do it. Well, that happens in our cockpits as well. We're not given many times a philosophy of operation. We're told just do it. And when we're told to just do it, and we don't understand a footprint, Dan Hanlon mentioned in one of his papers, there's a human factors footprint. There's a DNA that just makes sense to a pilot. Just makes sense. A philosophy of how you want me to operate your aircraft, meaning the pilot speaking to the certificate holder. And if we understand that philosophy, then we'll minimize selective deviation. Sathya, in your research, are you optimistic about any trends that you're seeing in the area of, in these areas in your research? Do you think things are on the upswing? Are you optimistic?
I mean, there are different, I don't want to speak specifically to the numbers, I don't know those offhand.
Sure.
But in terms of trends, you see different types of accidents. For example, CFIT, so controlled flight into terrain.
Right.
That was one that was a big problem, and it was #1 in terms of the commercial accidents, say 5 years ago. Now you can see that trend, those accidents are reducing.
But that was largely solved by mechanics or by a system in the airplane.
So you do have the systems. And the other thing to go about those are human design, human-centered design in those systems.
Within those individual systems.
In order for it to be designed, in a way that the human can understand it, it's not complex, extraneously complex.
Right.
And it's made in such a way that would maybe flow with how the human would think about the problem, and also give non-ambiguous cues. So all of, as Immanuel said, the human is in everything, and considering the human in every step is really important.
Right. Well, great point. So what I'm gathering here so far is the integrated system of equipment, procedures. There has to be a philosophy to what we're trying to do, instead of just saying we've received this new piece of equipment. Even at my own airline, we just received some new technology, in terms of uplinking clearances to the airplane. And it sounded great when I was reading the bulletin, but it didn't sound so great and feel so great last Friday afternoon in Chicago O'Hare when I was trying to figure out, and my first officer was trying to figure out how to integrate this new system into the philosophy of how we're operating here with the 3 or 4 other things that I'm trying to do. Because we're linear thinkers. We want to get one thing done at a time. And so it's a difficult trade to put all of this together. But there is some good news. There is some good news. Well, before we do that, Dr. Barshi, do you think the certificate holders are getting it? I mean, are you optimistic as you do your research?
Well,
do you see improvements?
When I look at this room, I am optimistic because you guys have to communicate that message to your certificate holders, the companies. It's very difficult to sell safety, right? It's very difficult to demonstrate that you have prevented the next accident. And the bean counters know that a hull loss is $1 billion.
Sure.
But that's too abstract. And if you say we need, half a day of training, that's however $1 million throughout the company, they can see that right away.
Right.
And so the trick is to demonstrate how you're able to reduce the risk. And for that, collecting data is very, very useful. And relying on research, relying on data that has been collected in other places is very useful. The economics are going to continue to drive the industry.
No question.
And so, am I optimistic? Yeah, of course.
Good.
Otherwise, I wouldn't be doing
Absolutely.
what I'm doing.
So we've got to, I think your message is we got to continue to fight, but we can't think about this the way we did 20 years ago. We need to think of this as a human factors system and how all of the pieces fit together, human-centered operations.
There's one more warning that is probably useful at this point. We're actually doing so well as an industry that there are many, many more ways to screw up than to improve.
That's a great line.
Think about it as being close to a mountaintop. There are very few ways to get to the top, and there are lots of different ways to go down. And so we need to be very careful with interventions that we come up with that seem to make perfect sense. But we may be thinking in a very narrow way about just that particular piece, and we don't think about the whole system, when we don't think about the interactions between the technology, the humans, and the environment. Sure. And it might seem to make perfect sense. Oh, we should just add this line to the checklist, and we will never have that problem again. And the next thing you know, we have the same problem again because the whole checklist is dropped or whatever. So we need to be very, very careful with interventions to test them extensively and really consider all the possible things that we can think of, and remember that we will not be able to think of everything.
Now, here's some good news. We do have people in the industry, certificate holders, FAA regulators, Transport Canada, that are interested in understanding that this is a human factors system. So now I'd like to introduce Captain Rich Loudon from Alaska Airlines. And they're doing some innovative work in a very specific area where they feel that they can make a measurable improvement in the human factors atmosphere, a very specific piece of the human factors atmosphere in their cockpits. Rich, you got it.
Thanks, Frank.
You're welcome.
Thank you for the invitation, the Alpine Safety Forum, to come and speak and essentially just share our story. It is a human-centered operating procedures success story, we'd like to think. It started in about 2013. We were reviewing the NTSB's report on the Birmingham accident. And I was kind of working through that, essentially focused on the briefing the crew had done. And as I read through the briefing, you could tell that the pilot flying was checking off some sort of a list or a box, was following a procedure, if you will. And the other curious thing in that was there was very little involvement from the pilot monitor. So you've got two things going on that got my attention. Interestingly enough, in that CVR, you have a blah, blah, blah. And deeply troubling because I looked at our own procedure and kind of looked at them side by side and said, boy, those look the same. And they feel the same, too, sometimes. This required list of items to be briefing for every departure and arrival, a one-size-fits-all solution. And the things that would be troublesome that night were about 6 relevant threats that went undiscussed. There were no countermeasures, crew countermeasures regarding those things that ended up being causal. And so all that kind of had us thinking and troubled because it sounded so similar to ours. And I've spoken to many in the industry who would agree, oh, that's ours too. And so at the same time, we got our LOSA back. And we had that same significant troubling pilot monitor piece that is, we've got a lot of errors that are attributed to a lack of good monitoring cross-check. And we're working on that as an industry fairly well. The interesting piece that we did get was this briefing piece. And in our prior LOSA, we had some errors with our briefings, mostly omissions. It would occasionally lead to an undesired state. But it was the next LOSA where you have this disturbing trend in the wrong direction. The errors in briefings were increasing as well the undesired states. And again, I'll say that I think this won't be unfamiliar to many of you in the room because there's your average in the industry. We're all seeing somewhat of the same trend. And so when thinking about this Birmingham brief and our own brief and this disconnect, Dr. Klinek would say, you know what that is? You either got bad pilots or bad policy. And we, of course, assumed the latter, and so we looked at our policy. And I've been with Alaska Airlines flying for 25 years. When I got there in 1992, we had a departure brief that looked a little bit like this. And then the age of the glass cockpit came in the next decade. We got FMCs, we got RMP, and so on. And so there was all sorts of cross-verifications that needed to be included and tacked on to the list, if you will, because these needed to be cross-checked.
Hey, Rich, I had a question.
Mm-hmm.
Did you have to go into holding to complete that checklist?
Well, you would think.
Sorry to interrupt you there.
Again, but it is very similar to what we're seeing across the industry. And then the next decade was the threat and error management decade. And of course, we had to throw in the list of threats that now needed to be discussed at the end and so on. Now, everything in that list that grew and grew and grew is all important and really critical safety items. But what happens here is you're asking every crew to run through that for every departure and arrival and verbally go through it to be compliant. And so is it any surprise you start to see a disconnect in the data and that it's not working anymore?
So
and
that would be the selective,
the
Dr.
selective
Barshi?
Compliance, exactly.
Yeah.
And so that's what he's saying, is take a look at that. And so we got together, and I want to, and you'll notice in the upper right-hand corner, it's not a should, that's a will.
Wow.
All right? So by the wisdom of our flight ops leadership, they formalized a human factors working group about the same time as this LOSA return. And 3 or 4 pilots, they now bring us in once a month, and we do this kind of work. We were always there. They're at your airline, too. They're reading big books and poring over NTSB reports. It's what we like to do. But our Vice President of Flight Operations formalized this with the Director of Training, a group that was going to be dedicated to human factors. And we worked with safety and the fleet and with training. And we decided to look at the data and propose a new QRC, a quick reference checklist that would be in the flight deck for crews to brief off of with a new philosophy, if you will, on briefing based on the trend. We had 4 goals that we came up with. The briefing should be threat forward. It should be interactive. It should be scalable and cognitively based. And so let me go through those. Here is the tool. It's got our departure briefing, our approach, and a debrief tool that you can use there in the middle, and then a memory jogger for those times where it's really helpful of potentially relevant threats. And And so I'll zoom in on that to kind of go through some of these goals. We have an acronym that's there just to help the crews remember the flow of the new procedure. And so there it is, threats forward. And what we wanted to do is leverage that law of primacy. That which you discuss first is most likely to be retained. But what we found after using this for a while, what's great about having threats forward is it informs the plan. Because you're having this discussion about what's going to get us tonight or during this arrival. And once you have that discussion, then when you go to discuss how you're going to actually do it, that threat discussion does inform the plan. So that's the threat forward piece. And then the most interesting piece that I think I get the most questions on is when we decided to have the actual person on the flight deck that the data is now showing is a critical safety person on the deck is going to start this discussion. And so right now, flying over this country, our pilot monitors 30 minutes out from their arrival briefing, figuring out how am I going to answer that threat when the pilot flying turns to me and says, what are our threats? They're looking at the ATIS, they're running some performance, they're kind of thinking it's working. And we weren't sure how this was going to sell. And it was very well received, and we're actually doing that and pretty happy with it. And what we got out of that was an interactive brief. We've got some ownership and engagement from the pilot monitor. The third thing was that they would be scalable. That one-size-fits-all solution, we thought, well, wait a second, that's just not how we operate. I mean, there are times where things are more complex and other times when they are not. There's high and low risk. There's familiarity and unfamiliarity. So we wanted to view our professionals as just that. They know how to analyze risk. And if Helena and I are flying San Jose turns all month, we just did this yesterday. It is still calm winds, sunny day, same runway, same arrival, same approach. Having a big, long, lengthy discussion of a list of items that are required isn't going to help us perform that safer. So we'll be able to scale that briefing down because there's so much familiarity and low risk together. On the other hand, if she hasn't been there for a couple of years, that changes everything. And so I have to scale that up if I'm on that briefing. And so we extend that to our pilots to make those adjustments. And when you're going into severe weather or what have you, of course, that briefing is lengthy and well detailed. So that's the scalable piece, and relevance is a huge component to it, and deciding what is relevant today with either the threats or the plan. And then finally, the cognitive-based piece is at the end of a lengthy brief, it'd be nice to recap and summarize, and that's the principle of recency, that which is talked about last is also best retained. So we conclude with a recap of specific PM duties. Okay, we're going into Boston with 303/4, crosswinds, blowing snow, who knows what. I'm going to distill it down to some big ticket items that I need my pilot monitor to remember. I need a wind check at 500 feet. You're watching the radar, and if we aren't landing to our assumptions, you're probably going to be the first one to catch that this has changed on us, and so on. So we're going to finish and wrap up with that discussion. The entire structure was based on some great work out there with Cunningham and Gladwell. Our favorite was Dr. Gary Klein. He has worked with firefighters. They're constantly facing rapidly changing environments, and he studied how they do it. They do it very well. And he came up with some theories that are based on pattern matching, and that the way we make decisions when things get busy and it gets time compressed and it's changed on us is known, how you're going to actually come to the conclusion. It's called pattern matching. And so this briefing design is set up to anticipate the threats, discuss countermeasures, and in so doing that, you're creating pattern matches should they become apparent or present themselves on the departure or the arrival. You've already got the answer to the quiz. You've talked about it, and the recall is much higher in those situations. So that's the design under the hood, if you will, of this briefing. So where did all the other stuff go? Well, we moved as much as we could in what we call our setup. It's done silently, and it's done thoroughly, and it's well spelled out in our flight handbook, as are the details of this are well spelled out. This is a quick reference. But the setup is where each pilot goes through and ensures everything is as it should be. And we just asked for each item, is it really important that we talk about these things together? Because we're jealous for every word, right? It matters what we talk about in regards to how this plays out. So how was it received? We immediately followed up with a line check and LOE data to see if we were seeing the crews pick up on what we were moving towards. And as you can see, pretty good numbers there. That was good news. And then 3 months later, we ran a survey. How were you prepared? Well prepared were you? How did the training come across? And overall, what was your approval rating? And that 84% was a wonderful surprise. We always joke, there's always about 15% that don't like anything, and no matter how hard you try. But the training package was, we were told to, let's over-communicate this, let's over-train it. It's a sizable change, and so we did put together a pretty big training package, and then when we turned it on, we followed up. But that is our story.
Thanks, Rich. You stole my question I had written down for you. It's how do you know this is working?
Well, Tom Kemp's in the room. He's our VP of Flight Ops. He is asking the same thing.
Okay.
And so we do.
By the way, he asked me to ask you that.
It's important.
Yeah,
because
it is important
a
because
change like this, you have to.
Absolutely.
It's like, as Dr. Barshi said, be careful. And so we're watching our data streams very carefully. Our ASAP and FOQA data, all those departments are on alert to be watching for anything that might be briefing related. We're watching our AQP data. And of course, we're going to have another LOSA and be able to actually compare the last one and see if we can drive those briefing errors in the other direction.
Sure.
And the UASs as well. So, sure.
Well, here's another piece that goes with it. So let's see, we talked about the pilot group and the certificate holder, right? Then we talked about management, who invests the money in it, right? How about the regulator? What's your POI and CMO? How were they with this? Were they pretty open-minded with this, the FAA?
Yeah. Well, that's the human-centered piece, that we were bringing in the science with
Sure.
them. There was a huge approval of that and an affirmation that...
So they like that piece of it?
Absolutely, yeah. The story carries along as you can kind of show that not only does the data, the internal data, reveal that we need to make some changes, but we're going to do it scientifically.
Okay, so that's a key point. So far I see some takeaways here, and we're pretty much right on schedule. So Human Factors Working Group that included line pilots, which gave this whole process some street cred, right?
Yep.
That's an ongoing...
In our videos, we used our ALPA training chair and vice chair.
Okay, that's good.
We
That's
wanted
good.
them
It's
to know
good.
we had ALPA integrated into the
That's good.
design.
ALPA likes that. The FAA went along with this and actually enjoyed watching it when you backed it up with data, right?
Yep.
Okay, and then that is going to hopefully build a human factors system that has street credibility that the pilots will buy into, and maybe they won't execute or feel that they have the ability to selectively non-comply. Okay, got that, right? So we're kind of putting this together. And what do you think about this, Dr. Sathya? You think this is a pretty good plan? What's going on here?
I think it's fantastic. I think one of the most overwhelming things about incorporating human factors is, we talk about problems. This is what you need to do,
Right.
these are the problems, and humans are pretty unpredictable. And I think this is a great example of how, of a step-by-step process you can follow to actually see results. And that's another thing that I would hope that would take out of this panel is that there's been a lot of research that's been done. There's been
Absolutely.
30, 40 years of human factors research
Use it.
specifically in aviation. And there are a ton of tools that are available to incorporate the human element into every aspect of the operation and design.
Great.
So I think that's just important to keep in mind. It's possible to get to that point, and I think this is a great.
Great.
segue.
So it's an ongoing effort, right? So what's the next one you're going to tackle? You did departure briefing. You got any ideas? Can you give us a sneak peek?
Yeah, we've got a lot of work going on, and event management is one of the ones, leveraging Cunningham System 1, System 2. Maybe folks have heard of that, but that's trying to convince our captains it's a good idea to give the aircraft to your first officer during a complex abnormal.
Okay.
Leveraging the way our brain processes information in a complex environment. So, absolutely.
So you're going to change human behavior a little at a time?
Hope so.
But you're going to give them a system that makes sense. Okay.
Yeah, we're going to explain the why.
All right, that makes sense to me. Okay. All right, here's one of my heroes. She's up last. Helena Cunningham, for those of you in the audience, AKA Rydamar. But Helena, I want to personally thank you for all the work you've done at the Airline Pilots Association for our profession. Now, the good thing about Helena, among many other really good things, is that she's out flying in probably the most difficult airspace in the country as a relatively new captain. She's flying the 717, pretty much on the East Coast, right?
We went all over, yeah.
You got to wander around in that airplane, but you're doing some tough work out there. You're doing some work that's new to you, and as a pilot in command. So you've been out there on the very difficult airspace. You deserve it. You got the floor. What are you seeing out there? What can we do better? Tie us into what you're, just talk. You got it. You got it.
Well, first, I just wanted to talk about what the last thing that Rich just said that I think is so important, the why.
Yes.
Tell them the why. So before I jump in, I think that's a really crucial piece. If you tell the why, chances are you'll get compliance. People like to know why. Pilots like to know why. So, all right. So over the past few years, we've started, ALPA Human Factor started looking at how actual procedures figures into incidents that are attributed to pilot error or human error. And I'll be honest, it was probably peaked a little bit by all of the mergers. We started blending procedures, so many mega mergers and so many layers of procedures. So considering that perhaps the procedures themselves were the cause of conflict between the human limitations and the demands placed on the pilot by standard operating procedures or SOPs. I'll just call them SOPs, I don't want to shorten it. So when SOPs were first introduced 30, 40, maybe even 50 years ago, the concept was enthusiastically embraced. Everybody loved them for good reason. The safety and efficiency aspect of, or the value of standardization is so great it's almost unquantifiable, I would say. And it's safe to say they were wildly successful. And over the decades, they've been tweaked here and there, usually in response to accidents or incidents along the way. So it's not uncommon today to have SOPs that are somewhat contradicting at one airline. So bottom line is all SOPs are not created equal. And speaking to that, we at ALPA realized that there's a little more to it here. We need to get in front of this. So we recently updated, as a matter of fact, I think it was just passed in April, our ALPA admin manual is now recommends that we have human factors expert when developing procedures. So that's an actual ALPA recommendation. So the ALPA Board of Directors adopted formal language supporting a human factors approach to all things that we do in the Air Safety Organization, from pilot assistance, from security to aviation safety. So we're hoping that everybody else will follow. And it's time to move to the next generation of SOPs. And what that means, as Immanuel has alluded to here too, is that we use a standard process for procedural development that looks at and considers the entire system. The interactions between the human, the technical aspects, the entire environment, that specifically uses known science of how our brains function. We know much more about the cognitive processes of the brain today than we knew 40 years ago. So pilots come with varied skill sets, but our brains tend to function very similarly, believe it or not. We can develop procedures that leverage the human strengths and they mitigate our limitations or our weaknesses, let's say. So what are we good at? What are we bad at? What do we look at? What do we do every day? Things that we encounter every day that sort of looks at all of that. We're good at habit patterns, for example. like flows. We're really good at that. That's considered procedural knowledge, and that resides in long-term memory stores. We do really well with linear and methodical. Declarative knowledge is our memory of facts and figures. It's not as good as our procedural knowledge. It's more working memory associated, use it or lose it. Working memory should be kept at no more than 3 items. And under stress, even 3 items can be too much because we may not be able to accurately recall that under stress, particularly in no time or low time emergency situations. So let's talk about prospective memory, our most fallible memory type. If you have prospective memory in your procedures, you may have some issues, should be avoided. We're not very good at intending to remember to do something. One distraction, and that intention's easily forgotten. And oftentimes, cues can be entirely missing to alert the pilot that something hasn't been performed. So reliable, robust, consistent anchors and cues are essential for all safety critical procedural items. The human brain is also prone to perceptual issues. If you've heard about illusions and biases and expectancy effects. For example, looking without seeing. We see that in reports all the time, don't we? It's easy to look at a gauge and see what you expect to see, not what's actually there, because you've done it 1,000 times. Perhaps an actual switch position response or a tactile check would be more appropriate if it's a really safety critical item. So we have attention issues. We looked at that a lot when we went through the monitoring research. It's not natural for us to give active attention to unchanging displays. And here's a big one, multitasking. Many times our operation demands multitasking, which we can't actually do. We are, however, very adept at task switching, and with experience, we get very rapid, I've heard something like 10 to 13 switches per second as experienced pilots. But anyway, pilots routinely juggle many tasks concurrently with frequent interruptions. Information and tools are often missing or unavailable. Think single engine taxi while you're still waiting for your weight data. This leaves us vulnerable to errors. And you can't oversimplify that by saying it's pilot error. And particularly if there are repetitive errors in a certain phase of flight, maybe a look at the procedures in order. And as we've heard from both Dr. Silva and Dr. Barshi, there are procedural design tools that can help to develop human-centered operating procedures that take the features of the operating environment into account and help the users meet the complex demands. Our airspace is very complex. Our airports with construction and all of the automation technical pieces, it just becomes very complex. But there are tools that can help us. So human factors and procedures have come a long way. The FAA has funded extensive research into procedures development particularly. And there's a new advisory circular out this year on monitoring and procedures. There's a great deal more knowledge available today about how the pilot best interacts with their environment, with the technology. And in order to develop these human optimized procedures, there really needs to be a thorough understanding of the complexities in the interactions. So there's a lot of interest in getting this right by all the stakeholders. So bottom line is that we have the knowledge to improve this operating environment. If the procedures are intuitive, they tend to be operationally efficient, and that could help with the on-time metric, which is so important today, and also potentially improve flight path management if it focuses your attention.
Sure. Great, thanks, Helena. That's fantastic. While you were talking, I thought of something I had just taken a note on. Scotty Hammond and I talked earlier today, maybe we should expand this and look at standard operating principles. You certainly have procedures to be part of it, but maybe when we're discussing this as a system and as a philosophy, standard operating principles are really what we're trying to drive home today, that's characteristics of a system. The procedures are the nuts and bolts pieces of it. I think that's another good takeaway. I want to have time for a couple questions from the audience. My son is at the Coast Guard Academy in basic trainings in week 4. Right before he left, we were doing all this stuff before he left, and he was doing something on the computer, and I'm talking to him. He said, "Dad, stop, you're distracting me." How many people have ever said that in the cockpit? We don't want to say that to the person we're flying with. Stop, Linda, stop that. Just hang on for 1 second, you're distracting me. I need to finish this. We don't want to do that as pilots because we're supposed to be supermen, right? We can multitask, do everything right. Stop, you're distracting me. We should need to empower each other. That's part of the system that we need to communicate with it. You're distracting me from it. Hang on 1 second, we can talk about that over a beer. So that's another, yeah. The bottom line is, we're not trying to solve the world problems here, aviation problems. We're just hoping to get this started, that we have a lot of data. We have a lot of expertise. ALPA's endorsed this, the FAA has endorsed it, that we need to wring that last bit of juice out of that lemon, right? We can do it. It's going to be hard because there's no easy fix. There's not a new system we can plug in that's going to stop CFIT or going to help us with predictive wind shear. It's hard work. The regulators are going to have to help us. The certificate holders are going to have to empower and endorse it and give you the resources to do it. But we can make things better. It's a journey, and it's just starting. Thank you, Mark. Great panel.
Thank you, Frank. And the panelists, what a fascinating
Great
discussion.
panel.
It's really awesome. Thank you all very much.
Great takeaways. Thank you. Thank you all.